All right, here we go. Continuity.
Stop, that's disgusting.
Here's a function of g. Where is it continuous? We got to name the intervals. So you got to know interval notation. Do you remember interval notation?
No. Yeah, I'm really good at
So anytime you use infinity,
Taylor Boothie, Molly Murray. Please report to the office. Taylor Boothie, Molly Murray.
anytime you use infinities, it uses a parenthesis. So from negative infinity up to what is it continuous? -1. Now, -1 would have a bracket.
Because it can be equal to
Okay.
1, but it can't be equal to
Where else is it continuous over an interval? -1 to 1. Where else? 1 to infinity. Okay, so we will be working with continuous, and they'll ask you various questions about, is this continuous over this interval? Is this continuous over this interval? And so on. So, all right, then, is f of x continuous over all real numbers? How would you figure that out?
Good question.
Well, maybe you would graph it. Let me see if I have my graphing calculator on here yet. Yeah, I used Desmos the other day. I'm going to use one like yours. There. So if we go y equals clear, well, that's turned off anyway. So, and go e to the x. Second, ln is e to the x, and we graph it. What does it look like? Well, it looks like it's going up. So it's really a function that goes forever like this. Okay? So is that continuous? If it goes forever this way and forever this way?
Yeah.
Yup, it sure is. What about the square root of x function? What does that look like? Well, that looks like this, which stops right here, because can you have a square root of a negative? No. Is that continuous over all real numbers? No, because it's missing all these numbers over here. So it is f only.
Okay, so what does the other thing have to do with that? Yeah, why did we have to write out interval notation?
Yeah.
Oh, that's
This is a separate problem.
I was like,
These are separate problems. Sorry. This is actually a whole separate section. This is the first section you'll do, and then this is part of the second section you'll do. Okay? Then it'll ask, which of these are continuous at 0? Is cotangent of x continuous at 0? Well, I don't know if I would expect any of you to remember the exact way that's graphed. So, cotangent is the inverse of what trig function? Tangent. So it's 1 divided by the tangent of x. Now, I have to make sure if I'm graphing a trig function, it's in radian mode. So now if I graph it, that's what cotangent looks like. It's always decreasing. But see, what happens at 0? There's a what there? Asymptote. You guys are so good. So is it continuous at 0? No way, Jose. What about this one? What does that look like? Well, let's graph it out and look at it. So that one is 1 over x squared. So if we graph that one, it's going to look like this. Wonk. Wonk. Can you go 1 over x squared, 1 over 0 squared? No. So there's a what there? An asymptote. Are they continuous, either one of them? No, neither one of them are continuous there. Okay. What about being continuous at 2 for this one? What's 2 minus 4? -2. Can you take the fourth root of -2? No way, Jose. What's the log of 2 minus 4? What's the log of -2? Well, you got to remember logarithms, how they work. If there's no number down here, the base is 10. 10 to the what power? 10 to the what power equals -2? Nothing. So that's a no way, Jose one. So it's neither. Okay. So you'll have some like that. And then on the last section that you do, it says f is continuous for all x's. We're supposed to find f of 5. So basically, that's finding the limit as x approaches 5. So how would we do that if we were faced with this? This is a review. The conjugate. Very good, young lady. Square root of x minus 1 minus 2 over x minus 5. So we multiply it by square root of x minus 1 plus 2 on the top bottom.
What is that music? It's fire.
It must be...
It's over there.
Okay. Jungling. All right. So it would be x minus 1 minus 4. Okay. All over x minus 5 times x minus 1 plus 2. Well, this is x minus 5. This is x minus 5. They cancel. So if we put in a 5 here, we get 5 minus 1, which is 4. Square root of 4 is 2. 2 plus 2 is 4. This is 1/4. So that was what f of 5 would be if it's continuous. Okay? Here, x plus 7, x minus 7 over x plus 7. Those cancel. Put in a -7 here. You get -14. Boom, 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 boom. Okay? We can handle that, right?
Yes.
All right. So that you're working with continuity. I think it's out there already. All right. Stop recording.